Okay, so for this piecewise function, we have three parts to the function. So I'm going to do those in three different colors just to make it clear. You're welcome to bring colored pencils to the test if that makes you understand it a little bit better. Or you don't have to, either way is fine. So I have an x and an f of x, or y if you want. So in my blue function, I have x's that are less than 0. Remember, we always look at the domain first. That's this section to the right. I have x is less than 0, x is equal to 0, and x is greater than 0. I see 0 3 times. So when I break this up into 3 sections, I know I'm going to have a blue 0, I know I'm going to have a red 0, and I know I'm going to have a green 0. Now, all three of those can't be defined there or closed there. There's only one value that's closed, and that's the red one is closed. That means the blue 0 is open and the green 0 is also open. That's because it can only be defined at one value because a function and every x can only have one y. So it's only defined at the red. But you have to graph both the blue and the green, and if you don't, then you're not actually going to be going all the way to the endpoints. You have to plug it in 0 into all the endpoints, even though it's open. You have to graph that part. So other blue values are x is less than 0, so that's -1, -2, -3. For the green values, we need x is greater than 0, so that's 1, 2, 3, and it keeps going, which means we have arrows. And then I'm going to plug them in. This right here to get the x's is the hardest part. The rest of the plugging in and the plotting isn't too bad. Picking what x's I'm allowed to use for blue, what x's I'm allowed to use for red, and what x's I'm allowed to use for green, I think is the hardest part. Now once we plug -3 in, -3 squared is +9, -2 squared is +4, -1 squared is +1, and 0 squared is 0. In the red, if x is equal to 0, y is equal to 5. That's the easiest one, I think. Sometimes people get a little confused because there's like not very much to do there, and so they think it has to be harder. For the green, I'm going to write that one out. 2 times 0 is 0 minus 3, that's -3. 2 times 1 minus 3, that's 2 minus 3, or -1. 2 times 2 is 4, and 4 minus 3 is +1. 2 times 3 is 6, and 6 minus 3 is +3. And then it keeps going. So for my blue, I have -3, +9. All points are closed unless they're denoted as open. So that's a closed point, -2, 4, -1, 1, and then the only open point is the 0, 0. So that one looks like a parabola with kind of its arm cut off a little bit. Notice I put an arrow here because I'm the one that stopped at -3 because I just don't have time to finish it all. But I do know that it could be -4, -5, -6. So that's why I put an arrow there. At 0, I have 0, +5, and that's just 1 point. If you only have one domain value, you can only have 1 point. And then for the green, I have 0, -3. That's an open circle at -3. +1, -1, that's closed. 2, 1, that's also closed. 3, 3, all of those points are going to be closed except for the one open value. And if you pass a pencil through that, that passes the vertical line test. And that finishes that problem. For the next problem, we have evaluate the difference quotient for the given function. Now, I gave you the difference quotient here, and then I gave you the function. So you don't have to memorize the difference quotient until you get to calculus. So let's focus on just that red part, f of x plus h, because that actually takes a lot of our effort here. So what that means is every time I see an x in f of x, I'm going to plug in an x plus h. So I have x plus h quantity squared, because that's x squared, minus 5 times x, but I'm taking out x and replacing x plus h, plus 7. This is going to require a little bit of effort because x plus h squared means x plus h times itself, x plus h. So when I distribute, I'm getting x squared plus xh plus hx, but I'm going to rewrite that xh just so they're the same, plus h squared minus 5x minus 5h plus 7. Now those two are like terms, which means they add up. A lot of people make a mistake here because they forget that there's an invisible 1 in front. 1xh plus another xh is 2 xh's. Sometimes people will add the exponents or something like that, which is wrong. Whew, that was a lot of work, and I'm only like partially done because all I've done is that red part of my difference quotient. So I'm going to go ahead and plug that in to my fraction over here. I still have to do minus f of x, which we'll do in green. The f of x, because it's minus, means I have to put it in parentheses. The reason I have to put it in parentheses is because the minus has to go to everything. This is all over h. Okay, so we have the red is going to stay the same, and on this next step, the only thing that I can do is distribute the negative through the green. Negative 1 times x squared is negative x squared. Everyone gets that one right. It's the other two that sometimes they mix up if you don't have parentheses. Negative 1 times negative 5 is actually plus 5x. Negative 1 times 7 is negative 7 over h. At this point, a lot of things should add to 0. X squared and minus x squared add to 0. Minus 5x and plus 5x add to 0. Plus 7 and minus 7 add to 0. In fact, all of the green values should add out to 0 with some of the red values. All of the red values that we have left should have an h in it. And they do. And so what I'm going to do now is I'm going to factor an h out of the numerator. And now that it's factored, the h and the h divide out, and you're just left with 2x plus h minus 5. And that is my difference quotient. For this next problem, it says, given the following functions, find the composition. So it says f composed with g of x. So I am going to use colors again. I know I like my colors here. I'm going to use all of my f's in red and my g's in blue. So when I'm trying to find f composed with g, an easier way to think about that is f of g of x. This is an easier way to write it. Notice the f is still in front, the g is still second of x. It's just an easier way of thinking about it, even though that's technically the definition. So the first step, I know I have to work inside to out, so I'm going to take the g of x, the blue g of x, out and replace it with what g of x is equal to, which is 3x minus 1. And I think that's the easy step. The hard step comes right now. I need to take the function f of 3x plus 1. Well, what does the f function say? The f function in red says x squared plus 5, x squared plus 5. But I'm going to remove the x, and instead of x, because that's what function notation does, removes the x and replaces it with whatever's inside the function, which in this case is 3x minus 1. So we get 3x minus 1 quantity squared plus 5. When you square something, that means you're going to write it out twice. So I'm going to double distribute 3x times 3x is 9x squared minus 3x minus another 3x plus 1. At this point, people are spending a lot of time doing the 3x minus 1 quantity squared, and students will sometimes drop the plus 5. Please don't be that student. You have to keep this plus 5 coming down all the way so that when I combine like terms, I'm getting 9x squared minus 3x is minus 6x, and then plus 1 and plus 5 add to plus 6. And that's my final answer. But a lot of times students will just drop the 5 and they're like, oh, I'll add it on the end, and then after a couple steps they totally forget about it. Don't be that student. Make sure you're writing the plus 5 all the way down. So in this next problem we have f of g of negative 3. Notice I'm using the same f and g, but this time I'm trying to plug in a value, not just any x, which I think is harder. I'm just trying to plug in one value. There are two methods that I showed you how to do this. I don't remember which method I called 1 and 2 in the video, but here's one of the methods. One easy method is just to take the answer from number 11, assuming you got 11 correct, And because the answer to number 11 is f of g of any x in the world. So if f of g of x is equal to 9x squared minus 6x plus 6, then g of f of g of negative 3 just means plug in negative 3 to the answer. So if I just plug in negative 3 to the answer, that will get me, let's see, 9 times negative 3 squared minus 6 times negative 3 plus 6. Exponents first, then multiply left to right, 81 plus 18 plus 6, which is 99, and 99 plus 6 is 105. So f of g of negative 3 is 105. If you can get number 11 correct, this is the easiest way to do it. Just plug number 12, the negative 3, into the answer to number 11, and then there's your answer. I think that's very simple. Now, let's pretend you couldn't figure out number 11. You're like, I don't remember, Miss Lay, I can't figure this out. You can still get number 12 correct, even if you don't work out number 11 correctly. And you'll just have to use the other method. Okay? So what I'm going to do is I'm going to evaluate g of x. So I'm going to come off to the side of my paper and just evaluate g of negative 3. So that means just go to the original g function, which is 3x minus 1, and plug in negative 3, which is negative 9 minus 1, which is negative 10. So the blue part of this question is negative 10. So therefore, all I need to do to find the answer is just find f of negative 10, because g of negative 3 is negative 10. So I'm going to come down again off to the side of my paper and just plug in f of negative 10, which in this case happens to be negative 10 squared plus 5. Negative 10 squared is 100, and 100 plus 5 is 105. So therefore, f of g of negative 3 is 105. Well, there's no surprise here that the answers are the same, right? These are two different methods to get the same answer. If you happen to do both methods, what you've just done here is you've checked your work for number 11. If these two come out to be the same, then you know you had to have done number 11 correctly.